And then when we're done with this, I just want to talk about the final project, because she'd sent back the design, the study, and just had a couple questions. So I just wanted to go over that with everybody. So.
Oh, and since you brought that up, I wanted to bring, we're not all supposed to submit it once it's been approved, are we?
No, it only needs to be submitted by one person for the design, the study, and then everybody does the study. But then there is something that we all have to do, but I think that's at the end.
Right. Okay. Because I had a thing up like on course schedule on the upper left that like went red. And when I clicked on it, it was this, project first submission thing. And so then I'm like, okay, I need to ask my group, because I was under the understanding that just one of each of those things are submitted.
Correct.
Okay.
Ready?
Yeah.
All right. So, question 3. Out of the 70 females in the sample, 52 can taste PTC. Out of 59, 42 can taste. Please use the data presented here. Okay. So let P1 be the proportion of females of the population and P2 the proportion of males. The research question for the study is given here. Is the proportion of females who can taste PTC different from the proportion of males who can taste PTC? Use data to find the P hat 1. Hat 1 is the number of females, proportion of females.
And that's where we plug it all into the categorical data analysis, right? For the 2 proportions.
Yeah. And I've got that up. I just want to make sure that I'm getting the no, the yeses, and the total all right. Let's see. So it's 52 out of 70 that can taste, right? And 42 out of 59?
Yeah.
Oh, it's different numbers than in the, right. So next one. This going back and forth kills me.
I got 0.743.
Yeah, that's what I got.
Okay.
Ish.
Okay.
Okay, I got to make sure I'm putting these in right. So I'm going to go 52, 70, and 42. I'm sorry, I still feel like I'm rushing. And the type of test, confidence level. See, I don't have to worry about the confidence level or the type of test in my squares over by where it's purple.
Where it says inputs? No. You're
Got
just doing the, right.
So,
Ask us later, though.
all right. So use this data in the table to find P hat 1, 0.743.
Mm-hmm.
Okay.
Yes.
All right. Yay. All right. P hat 2.712.
Yes.
Right. So which set of hypothesis tests is appropriate for addressing the research question?
Is
Now,
it different? So it's not equal.
For the hat one.
It's the first one.
It's the first one, right?
It's not the P hat. It's the, no, because there's not, the other one had P hats in the bottom.
Yeah.
So it's
Okay.
P1 equals P2 and P1 does not equal P2 because they said different.
Why
Yes.
isn't it the fourth one?
because that's p hat. That's p1 and p hat. You see?
Oh, yeah. Okay. All right. Yes. It was the trick. Okay. Thank you.
Right.
Yes. Okay.
Yeah. So when you first look at it, you're like, aren't they the same? And then you go, oh no, wait, that's p hat. The alternative is p hat, not p.
Right.
So now you have to create the 95% confidence level for P1 minus P2. So if you go back over to the,
Where do you find the point estimator at? Is that the margin of error?
This
Oh,
was. Go ahead,
What
James.
did we get for number 4? Sorry, did we get 0.712?
Yes.
Yeah.
Okay. Cool.
And 5 is the first one.
Yeah.
And then we're 6. Okay.
So I started this about an hour ago, and this confused me like you would not believe. I tried to reverse engineer every set of numbers on here to figure out exactly what was going on. And I don't really remember reading this, but I figured out that based on a formula that I thought it was, well, I also was in my brain thinking of if you have a p hat or confidence interval, an upper confidence interval, and then a lower confidence interval. The point estimate for the overall interval would be in the middle. So I went down to the part where it says confidence interval for P1 minus P2. I added those two together and I divided by 2. And I also noticed that I got the same answer as if I,
Don't you don't subtract just the 2?
well, on P hat, if you look at my screen.
Yeah, don't you just subtract the
To get the
0.743 minus the 0.712?
And that's what I figured out later. I realized that they're basically the exact same thing. You could subtract this one from this one and get the middle, or you could add both of these together and then divide by 2, and you get the exact same answer as that. And that seems to fit with the formula that I saw earlier for figuring out what these things were. Let's see, was it this one? No. No, well, forget it.
So it would be 0.031 for that one?
Yeah,
Point estimator?
that's what I am close to positive.
and that's your p hat minus your p hat 1 minus your p hat 2.
Yes.
Right.
The answers are the same, even though they start with different numbers.
Okay. I was still trying to catch up here. I wanted to get my margin of error calculation in here. I add that to every one of my spreadsheets.
Yeah, I do the same thing. As soon as I open this up, I do that as well.
Okay, so because I was doing that, I was missing your whole conversation about point estimate, both between p hat 1, p hat 2, and the confidence interval level.
Yeah.
You found it both ways, right?
I found it both ways.
And
then-
so which way are you guys all doing it?
I'm doing 1 minus 2.
Is that the rule? Is that the rule though?
P1 minus P2?
Yeah, or is that just coincidence?
I have no idea.
Yeah.
So you took negative 0.123 and subtracted 0.185?
No.
No, 0.473 minus 712.
Oh, okay. The p hat 1 and the p hat 2.
Mhm.
Okay.
And then what I did was I added the upper bound of the confidence interval to the lower bound of the confidence interval, and then I divided by 2. And I got the exact same answer. So I think they're the same, but I don't know. I would love to be able to have this question happen a few times and see correct answers to determine if
So the
indeed-
point, right. So the point estimate is 0.031.
that's
Yeah.
that's what I believe it is.
Okay. Fabulous. Okay.
And I put that on my spreadsheet also next to my margin of error.
Yeah.
0.031. Okay. So question 7. What is the margin of error for this 95% confidence interval? So, okay. So
0.154. Right?
I concur.
Yeah, that's what I got.
154. Okay. Now, but you put that on your spreadsheet. So where did you put that on the spreadsheet?
Go ahead and look at
Right next to
mine.
the confident in G what? G20 and 21. So in G20, I put the title margin of error. Then in G21, I did the formula, which is equal sum, parentheses, F21 minus E21, close parentheses, divided by 2. If you need me to repeat that again, I can.
Oh, 0.185.
No. 0.154.
Oh, no. Okay.
F21 minus E21 divided by 2.
21 minus B21 by 2. 0.54. Okay.
1.154.
Correct.
Yeah, 0.154.
Okay. Okay. All right. So A is just the negative 0.1238. I mean, number 8.
Yes.
Yeah.
Negative. I swear, every other time, one time I'll join you guys and I think I'm not getting it. The next time I think I'm getting it. Which is why I'm like double checking. I need the confidence of saying my answer and you guys going, yes.
It's extremely iffy with me as well.
Well, because when it's in the spreadsheet, right, and you don't have to do all the calculation, you think this doesn't make sense. It's too easy.
Right?
It's not supposed to be easy. So, my goodness. So with the is everybody okay up to question 9?
It is.
I am.
So with the level of significance of 0.05, what decision did you make? So what
I
did
got
we-
the first one.
I agree.
Yeah, because everything's low.
The P is extremely high.
Yeah, no, yeah, you're right.
Okay.
Right. The
I'm
P
looking
is
at the P
0.6,
value,
right,
0.53.
0.653. So
Keep the guy, which is fail to reject.
correct. So it's the third one.
No,
No.
first one.
First one, right?
No,
Yeah.
you fail to reject don't you fail to reject the alternative?
No,
No, you fail to reject it. Sorry, you're right. Sorry. Wow.
it's always about the HO, right?
Yep, it's always about the HO. Correct.
Okay.
Again, another trick one.
The alternative, I just always think that it's only in the last little outcome of the study where you include the
Right.
The English sentence.
yes.
Yes.
That
Yes.
always get me on exams.
Yes.
Yeah.
So we failed to reject it, so there's insufficient evidence.
Mhm.
So there's insufficient to suggest the proportion of females who can taste is less than.
Mhm.
I think it's the fourth one.
Yeah.
Again, we're looking at the difference, not less or more.
Right.
I agree.
Oof, it's exhausting.
It's because we're flying.
Okay. right, so now the next group of information.
Oh, died and survived. Okay, I'll read so I can get it in my head if you don't mind.
Go ahead.
For the next 9 questions, we will review the mortality rates and day of admission heart attack study with different data. I never go to the hospital on a weekend. That's what I learned. Out of 118,519 who had a heart attack during a weekday, 16,713 had died. Out of 42,447 that had a heart attack on the weekend, 6,155 had died. Please use the data presented here. Let P1 be the proportion of patients who had a heart attack and were admitted on a weekday. So that's the first group 1. And let P2 be the proportion patients who had a heart attack and were admitted on a weekend who died. So we're going to use the first number, the died, right? The
Right.
research question for this study is given here. Is the proportion of patients who have a heart attack and are admitted to the hospital on a weekday who die less than the proportion of patients who have a heart attack and are admitted to the hospital on the weekend who die? So we're looking at less than, not equal.
Yeah.
Yes.
And it's a
And we're
proportion.
going to use like 16,713 over 11,8,519.
Correct.
Okay.
And then for X2,
713 over 118,519, and then 6155,
And 42447.
42447, 42447. And then right now the type of test is P1 is less than P2, which I can leave it for, at least on mine, it was defaulted to that already.
correct.
Yeah.
Okay.
Okay, so,
Oh, we have to do the conditions for conducting a hypothesis test are satisfied.
Yeah, and they're both above 10.
Right.
That's that upper box towards the middle.
Yes.
well, it says, yeah, where it says check all requirements.
Yeah.
Yeah.
The first sample and the second sample.
So they're both, so yes, they have been met.
The 12 is true.
Yep. Which set of hypotheses is appropriate? So this is the bottom one.
Bottom, yes. I agree.
I agree.
Okay.
Use the data in the table to find p hat 1, 0.141.
Mm-hmm.
That is what I have.
Use the data in the table to find p hat 2.145.
I agree.
The z-score, negative 2.020.
Given
In
the,
17, the shading would be to the left, right? Because it's less than.
Yes.
correct.
Correct.
P-value is 0.022.
0.022.
That is what I came up with. I agree.
So what is the decision? So it's 0.02, and if the level of significance is 0.05, so it's less than. So we reject.
I believe that is correct.
So if we reject, there is sufficient
Sufficient evidence.
that is less than. So it's the
Third.
second one.
Third one down. And I have a question when you guys have that all filled in and before you submit. Maybe you guys know the answer.
Yeah.
Okay, I think I recall reading in some of the material that if 0 was in the confidence interval, that there is not a difference between the two proportions. And that seems like it contradicts with our p-value being low and rejecting the HO. So did I misread something? Or is that true if 0 is?
So your little note down here at the bottom, if 0 is in the CI, there's not a difference between, because it's so small.
I actually put that little note in the yellow there. I did that.
No, I knew that. I knew that.
Yeah. And then I started filling in the data, and then this popped up 0, and so I go, oh, son of a gun. I've got a conflicting thing, at least a conflicting thought in my head, that if this is 0, there's no difference between the two proportions. So it seems like if there's no difference, we would have to.
So 0 is in the confidence interval. We cannot tell if there is a mean difference in whatever the for the confidence interval. So it's back to lesson 12, I think. So if it's 0's in the confidence interval, then we cannot tell if there is a mean difference.
Okay, so it has nothing to do with
P-value.
to reject or reject. It just was something that I read and I'm getting confused by.
Yeah, it's in the confidence interval, and if you go back to lesson 12, you'll see.
Okay. Okay, no, that's good. And then I'm going to delete my note. I'm ready to submit when you guys are.
$100.
Sweet.
That was easy.
Joan, you are too mucho.
Fabulous. Zinger. Okay.
Alrighty. So, hello, Pat. Is everybody okay with the?
Yeah.
Yeah.
All right. So I'm going to stop the broadcast, but let's talk about the design the study for a minute.